Hey there, iOS developers. Interested in getting started with Cloud Firestore, the hot new database in the cloud for mobile apps? Hey, me too. Wow, what are the odds we'd meet together in a video like this? Well, let's work together to save our data to the cloud on this episode of Firecasts. So I'm working on a little app here that lets me store an inspirational quote. I mean, I can't just be expected to start doing work, right? I need an inspiring quote, preferably from like Einstein or maybe Marilyn Monroe, to motivate me. And what better way to do this than with an app? So my app here consists of a text field where I can enter my inspirational quote and another one where I can save the author's name. And then we've got a save button where we're going to save whatever inspiring message our user has entered to the cloud. Later on, we'll load whatever data our user has saved to the cloud and display it at this big label here at the top so we can see the latest inspirational quote that we've entered. So if you want to follow along, go ahead and create your own version of this app. It really is nothing more than sort of these UI elements here. Just make sure you have some IB outlets for the text fields in the label and create an IB action for the button called Save Tapped. Now, I've already gone ahead and created a Firebase project in the Firebase console, installed Firebase using CocoaPods, copied over my configuration file to my new XC workspace, and initialized the Firebase library. If you don't know what I'm talking about, check out this Getting Started video here and the link in the description below, and then come on back. It's okay, I'll wait. All right, next we need to make sure we install Firestore. So I'm going to go into my pod file here and make sure I've added a line for pod firebase/firestore. And then I'll save that and run pod install to install the new library. So I can open up my XC workspace and I am good to go. Now, before we go ahead and write some data, let's take a moment to understand how Cloud Firestore data generally works. Frankly, this could be the subject of its own separate video, and it probably will be one day. But this here's the executive summary. So Cloud Firestore is a document database. That means it kind of stores your data in a big tree-like structure, kind of like the original real-time database, but everything is placed into documents and collections. Now you can think of a document as something like a dictionary. It's got key value pairs, which the Firestore folks like to refer to as fields. And then values of these fields can be any number of things, from like strings to numbers to binary values to little JSON-y looking objects that the team likes to call maps. And collections are basically, well, collections of documents. Now there are a few rules around the use of these things. The first is that collections can only contain documents, nothing else. No collections of strings or binary blobs or anything else here. Second is that documents can't contain other documents, but they can point to subcollections. So it's very common to see a collection containing a bunch of documents, which then point to subcollections that contain other documents, and so on and so forth. In a workout app, for instance, I might have a users collection, and this collection would contain a document for each user. And then each of these documents might point to a workout subcollection. That in turn contains a document for each different type of workout the user has performed. And I don't know, these might contain a history subcollection that keeps track of every time the user performed one of these workouts, along with like their average heart rate or other data. Now, if you're coming from the real-time database land, this kind of deep nesting might be giving you heart palpitations, but calm down, don't worry. This kind of data structure is completely normal in the Cloud Firestore world, where queries are shallow, meaning that when you grab data from a document, you'll grab just that document and not any of the documents contained in any of these subcollections, which is nice. The third rule is that the root of your database can only consist of collections. In a normal production app, this is going to feel pretty natural. You're going to have like your collection of items and your collection of users and your collection of games or what have you. The one time it's going to seem kind of weird when you're creating a little test app like ours and you just want to save like 2 strings. So looking at our app, at the top level, I'm going to start with a collection that I'm calling sample data. This will then contain one single document called inspiration. And this document will itself have 2 key value pairs, or fields, one called quote and another called author. Incidentally, note that this is basically a global document that I'm altering, meaning I'm not storing one quote per user, I'm just kind of letting everybody in the world alter this one document. If I were looking to save a different quote per user, I'd probably be setting up a users collection and creating a different document for each user. Make sense? All right, let's start building. So first off, in my view controller, I'll make sure to import Firebase. Remember, that's all I need to import no matter what specific Firebase libraries I'm using. Next, in my Save Tapped call, I'll grab the text from my text fields and maybe check to make sure that they aren't empty. Do that for both of these. Okay. Now, I'm going to create the data I want to save in my document. This will be a dictionary of type string any. And I'll use the key quote and the text field value as my value. And then we'll do something similar for the author. And yes, if this were a real application, I wouldn't hard code the key names like that. I'd probably be using constants. Okay, now I just need to save this to the cloud. And to do that, I need to specify in which document I want to put this data. And we do that through an object known as a document reference. Now, it turns out I'll be using this same reference multiple times throughout this project, so I'm going to make it a property here in my class. And then I'll set it down here in my view.did_load. Now, there are a few ways of setting my document reference. First, I could call firestore.collection sampledata.document_inspiration. Now, I kind of like doing this because it serves as a nice reminder that you're always going to alternate between collections and documents, but it does start to look a little verbose and kind of weird when you get several layers deep. So an alternative that I sometimes prefer is calling firestore.document, where I pass along a /separated string as our path. In our case, the path would be sampledata/inspiration. Just remember that in your path, you're always going to be alternating between collections, documents, collection, document, and so on. So now that I've specified my document, let's go back to my save_tap method, where I'm going to call setData on it, which will take in the data I created above as the contents of my document. Now this will replace my current document if it exists, and it will create it if it doesn't. It also conveniently creates the sample data collection too. I don't need to worry about whether or not that thing exists. Then in my completion handler, I'm just going to do some basic error checking, and well, that's about it. Let's give it a try. So I'm going to start up my app. I'll enter "don't be a slacker" here in the text field, and I'm pretty sure that was said by Sir Isaac Newton. So I'll hit save, and well, looks like I'm getting an authorization error. And this is because, just like the real-time database, my Cloud Firestore implementation contains a set of security rules that determine whether or not a certain action is permitted. And at the time of this video, by default, they're set up so that nobody can read or write to the database. So the proper solution here would probably be to add in some sign-in using Firebase Auth, and then create some proper, well-thought-out security rules based on what information I'm willing to share to each user. That said, all that would make this a much longer video than it already is, so I'm going to do a little bit of a hack here and make my sample data documents open to the public. So let's head on over to the Firebase console. I will select my project, go to the database section, and make sure I've got Cloud Firestore selected here for my database options. Then I will click on the Rules tab, and I'll add these lines here to allow reading and writing to anything that's part of my sample data collection. Like I said, this is probably a pretty terrible idea from a security perspective, but at least I've contained the damage to just what's in my sample data. So I'll publish that, and we are done. So I'm going to wait a minute and then give it another try. I'll go back into my app, hit save, and oh, all right, looks like it worked. And I can verify this by going back to the Firebase console. We'll select the Data tab. I'm going to look at our sample data collection, find our inspiration document, and sure enough, looks like we have saved our inspiring quote to the world. Woohoo! Okay, next up, we need to show our users their inspirational quote by grabbing that data and populating our label with it. Now, like the real-time database, Cloud Firestore lets me listen to changes in the database and update my app in real time. But I know that for some of you out there, the idea of creating a real-time listener for all your data is weird and strange, and sometimes you just want a basic fetch call to get it, right? So I'm going to show you how to do that first, and then we can talk about getting fancy with some real-time listeners. So I'm going to create a fetch button. I'll add a few constraints and create an IB action for it, and we'll call it a fetch tapped. Okay, let's edit this method. So I already have my document reference. As you'll recall, I created it as a property earlier. So I'll simply call getDocument on that reference to fetch the document. This comes with a completion handler, which I will make a trailing closure like all the cool kids are doing these days. And the two arguments passed in here are a document snapshot and an error. Now, a document snapshot is basically an object that represents your document. You can find out its ID, read some metadata about it, make sure the underlying document it represents really exists, and most importantly, grab the data that it contains by calling data on it. So first we'll see if our document exists, and if it does, we will call data on it to extract the contents of that document as a string any kind of dictionary. And yeah, I should probably add in some error checking too, but for brevity's sake, I won't. Next, I'll get our quote by grabbing data quote. Since grabbing contents from your data like this will always be an optional value, I'm going to use the double question mark operator to specify a default value here in case this is nil. And I'll do the same thing for my author name. And now we can do some fancy string interpolation to display this in my label. Incidentally, you might be asking yourself, hey, don't we need a weak reference here? But it turns out we don't really, because this block isn't retained beyond the fetch completion, so there's little risk of a retain cycle here. So we're going to run it, and there we go. I can now save my inspirational quote to the cloud, and then load it with a click of a button, and it shows up in my label. This is great. We've got our data successfully saved and loaded from Cloud Firestore. But what if you are interested in getting your data in real time? What if this explicit fetching seems quaint and old-fashioned to you? Well, let's show you how to get your data in real time too. Basically, the process is going to work nearly the same. Let's override view will appear, and in there I'm going to bring up my docref, but then instead of calling getDocument, I'm going to call add snapshot listener. And this will fetch my document the first time I call it, but then it will also grab updated data anytime thereafter when my data changes. This call has a completion handler with a document snapshot and an error, kind of just like my getDocument call. So in fact, I'm going to copy the exact same code from my get call into here to update my label, and well, that's actually it. So you might be asking yourself, hey, don't we need a weak reference this time around since this snapshot listener is going to stay around for a while? And it turns out the answer is still no, as long as we do the right thing and turn off these listeners sometime before our view controller is deallocated. That's not only good for memory, but it also helps to keep your network usage low, which means better battery life for your user and potentially lower database costs for you. So I'm going to create a little quote listener property here to track that listener that I created in my view will appear call. Then in my view will disappear method, I can just call remove on that quote listener reference. And there we go. That'll keep my app nice and efficient by only listening for data when this view is on screen. So let me run the app again. You can see that thanks to my snapshot listener, my label automatically gets updated with the inspirational Newton quote that was used previously. And then if I change my inspirational quote to this one, I'm pretty sure this was Gandhi who said it, you can see that my label gets updated automatically without my having to even touch that fetch button. Wow. Gee, that was fast. Maybe too fast, right? Looked like my label got updated before I even got that console message that my data was saved to the cloud. How'd that happen? Well, what's happening is that Cloud Firestore is making my app run as speedy as possible by notifying me of changes that happen locally as if they had happened on the server. But in the meantime, it's still going ahead and updating that data remotely in the background. Now, my client still receives an update from Firestore that this data has been changed on the server, but by default, the Firestore library will ignore this event because with the exception of a little bit of metadata that says, yes, this is really from the server, it's basically identical to the first. Now, if you want, you can also get notified by the SDK about this second event, the one that happens when the write actually occurs on the server. And you can do this by adding some options to your document listener that say, yes, notify me even when just the metadata changes, like so. And so when I do that, this callback will get called twice, once for the change in my local cache and then once for the server. And there may be times when this behavior is what you want, but most of the time, honestly, this default behavior works just fine. So I'm going to go back to that. And there you go. Congratulations, you are now saving your data in one of the most powerful and sophisticated online databases in the world and using it to store 2 lines of text, which maybe is a little overkill. But in a real app, you'll appreciate this power, trust me. Now, there's a lot more to learn about Cloud Firestore, including more details on how that data is structured, how sub-collections work, and how to run some more sophisticated queries, all of which are great topics for future videos. In the meantime, go back and change those security rules so they're a little more secure. And then when you're done with that, be sure to check out the documentation and try using Cloud Firestore in your own app. As the saying goes, the journey of 1,000 miles begins with reading the documentation. I'm pretty sure Miles Davis said that.